Welcome to the data structures class. Today we are going to discuss about stacks. So as you already learned in the starting classes, abstract data types are main important things in data structures. So abstract data types are three types. One is linked list or linear list. The second one is stacks. Third one is queues. So we in previous classes we discussed about what are the linear lists and types of linear lists. Now in this class we are going to talk about stack ADT or stacks. See, what is stack? Stack is also a collection of or group of homogeneous elements. Like arrays and linked list, stack is also a collection of homogeneous elements. But here in stack, the operations, what are the operations? Insertion and deletion. The operations both are done on top of the stack, done on top of the stack. So as you previously seen in the linked list, I can insert the element or delete the element at anywhere. I can insert at the starting or at the ending, or I can delete at the starting or at the ending, or I can do these operations at the desired position also, at the desired position. But in stacks, what I have to do, I have to done the processes at the top only. Whatever the operation, either insertion or deletion, I have to do on the top. So that means whatever the element insertion in the link stack, that will the first element which is going to be inserted in the stack will be deleted at last. Why? Because I am inserting one after one by one, one by one. Am I right? I am inserting at the top. So whatever the last element, I have to delete. Why? Because I am deleting also at the top only. Insertion at the top, deletion at the top. So whatever the last element inserted, that will be deleted. So that's why it is called LIFO. Here you can see LIFO, last in first out. Other I can say philo. Philo. What is philo? First in last out. Am I right? So first elements are inserted and deleted at the top of the stack. So the first element which is inserted will be deleted last. First inserted, last out. Philo. Either last inserted, first, last inserted, first deleted. Sorry, for last inserted, first deleted. That is LIFO. Last in, first out. So as you can see, this is the example for stack, I can say. Now most of the people know about this toy. Am I right? So these rings I have to place one after another, one after another. Now if you see, first I inserted the blue, next green, yellow, and red. I arranged the elements. You can say these are elements or rings. I arranged it like this. So if I want to insert another ring, I have to insert at the top only. Am I right? Below it is not possible. I can insert only top of the rack only. Am I right? Now if I want to delete the element, first I have to delete red ring, then orange, then yellow, then green. Finally I will delete the blue one. Right? Finally I will delete the blue one. Insertion and deletion. So it is one of the best example for stacks. So if you want the more examples, you can say, you can consider a pile of plates. So in restaurants you can see the plates are arranged in one by one, one by one. So if you want to take one plate, you can take from the above. So stack. Whatever the data inserted and lost, it will be deleted first. Now, if you come to the operations of stack, these are the operations. It has two types of operations. One is essential operations. The second one is non-essential operations. Essential operations are nothing but if you want to do work on the stacks, or if you want to perform some operations on stack, this is to push and pop are most important. The non-essentials are is not important. These are only for properties, to know the properties of stack, to know the properties of stack. See here, push is for insertion of element, push is for insertion of element, pop is for deleting the data. So both are done on the top. So if I want to do the operations on data, I have to do insertions and I have to do deletions. So that's why these two are very important or essential operations for stack. Then these are all non-essential operations. See here, peek is for knowing the what is the last element of the stack. What is the last element of the stack? Size is for representing how many elements or what is the size of the how many elements I can insert in the stack will be known by the size. Now is empty will explain is the stack contains any elements or not. The stack contains any elements or not will be known by the is empty. If you use is full, it is for is the stack is full or can I insert one more value. For finding that process, you use is full. So if I have 5 elements of stack, or if I can store the if I can store 5 elements only in a stack, so I will check is full or not. If stack contains 5 elements, is full deliver a true message. That means the stack is full, so I cannot insert. If stack contains less than 5 elements, is full will deliver the false, that is 0. If it is false means I can insert the value. In the same way, is empty, if the elements are available in the one or more elements are available in the stack, it will produce false, that is 0. That means we have some elements. If it produces true, that means there is no elements in the stack. There is no elements in the stack. Now size, number of elements I can insert in the stack. Big is for to know the topmost element of the stack. So as you see, these are only for purpose or properties of the stack. Am I right? I'm only knowing the properties. Is it full or not? Is it empty or not? What is the top value? What is the size of the stack? Am I right? These are the properties. So these are not a essential. That's why it is these are non-essential and these are essential. So if I want to do operations, I need to insert, I need to delete. But these are not necessary. I can do in my own way. Am I right? So if you consider these six are the operations in a stack. So let's consider this one. It is a stack. So those are the operations: push, pop, peek, and is full, is empty. Now if you see, the stack contains the 5 elements, 1 to 5. The first position, second position, third, fourth, fifth position. But as you know, according to the programming, the first element will start from the 0th element. Am I right? The first element starts from 0th element. So if I take the addresses, it starts from 0. So if I want to access the first element of a stack, I need to access from the 0. I need to access from the 0. So the position is 5, but the stack addresses is 0 to 4. Now these are here. I am going to insert the values. Now let's check if it is empty or not. Now if I execute the is empty function, what will show? It will show a true message. Why? Because is there any elements? No, there is no elements in the stack. So that's why it will show you a true message. Now I want to insert a element. See here, push 10. I'm pushing a 10. That means I'm inserting a 10. So see here, I'm inserting from the top. So from the top it will check fifth, fourth, three, two, one. Oh, so first position you don't have element, so it will goes to the first element. Again I am inserting 20. Now again it comes from the top. So already 1 is filled, so it will go to the second position. That means the 1 address of 1. So in 0 we have 10, in 1 20. So similarly next I inserted 11, it goes to the third position. Next I inserted 28, the same process. Everything comes from the top. Am I right? Comes from the top, and at the topmost address space it will store. At the topmost available address space it will store. Now if I perform is full operation, is it full or not? Now check. It needs 5 elements. Is it full or not? Yes, it contains 5 elements. So the stack is full. It will produce it will produce true. So stack is full. Now I want to delete a element from the stack. Now I want to delete. So I will use directly pop. So see the difference. If I want to insert a element, I will use push element. But here pop. Pop operations are done on whatever the element is available on the top, it will delete. So there is no need to specify the value. So directly if I use the pop, that is delete, then automatically the above value, whatever the value above is deleted and gives as a output. Now pop produces a topmost element of the stack, produces topmost element of the stack as a output. Now that element is deleted. Now again I am going to do the pop. Now what will delete? The 28. Now 28 is deleted. Am I right? Yeah, 28 deleted. So okay, if I have done the process, it will done like this. So next 11 will be deleted, next 20, next 10. Then finally after 10 also, if I done the process, it will produce a wrong output, or it will produce a error message like stack is empty. Now let's see what is peak. Peak, what I already explained, peak will show you the last element of a stack, last element of a stack. Now if you perform the peak, it will do the two operations. The first operation is pop. First operation is pop. So if I perform peak, first it will pop the element. That means the last element will be deleted. Why? Because pop will produce as a last element to the output. Last element to the output. Now the output is 11. Then see, peak is for only displaying. So what I have to do? Now pop is deleted, so I have to push the element again. I have to push the element again. So here peak perform two operations. Peak perform two operations. Let's see again. So peak, if I produce the peak, first what it will do? It will perform the top. First it will delete and display the whatever the value at the top, it will be displayed. Next, I don't want to delete the element from the stack, so immediately it will apply the push operation. So the combination of pop and push will become as a peak, will become as a peak. Now, so we discussed what is stack and what are the operations of stack. So those 6 operations we have discussed. Now I have to implement the stack. I have to implement the stack. What is the implementation means? I need to create a stack and insert the values and delete the values. But if you consider integers, if I want to perform a operations on integer, what I have to do? Int and variable name. If I want to do operations on arrays, int space array name. Am I right? But if I want to perform a operations on stack, there is no special type of special data type for stacks, right? There is no functionality, nothing at all. We have to do whatever the available functionalities, we have to apply those. So if you consider linked list, I have used structures. If you consider strings, I have used the string keywords. But for the stacks, you don't have those types. So that purpose, I'm going to implement stack by using arrays and linked list. So we have already operations for structures for or definitions for stacks. Sorry, arrays and linked list. Am I right? For array, what I have to do? I need to write the data type and name of the array. But if I want to perform a linked list, I need to create a structure with the following property. If it is single linked list, I have to measure two properties. If it is double linked list, I have to create with three properties. Already you seen in the last video. But when I use arrays and when I use linked list, see, as already you know what is array. Array is a collection of elements. Linked list is a collection of elements. But what is the difference between array and linked list? Array stores the elements in a continuous memory allocation. In a continuous memory allocation. But linked list doesn't need to store in continuous allocations. You can store in different positions also, but we can connect with the next address field. Alright. So that is the main difference. If I want to create a stack with a dynamic memory allocation, then I will prefer the linked list. I will prefer linked list. If I don't have a restrictions, I can directly reserve if I want to do the operations and type. If I want to do operations and stack, now I have a direct access. So if I want to create 10 elements, I have a space for 10 elements directly. Then I will go for arrays. If I don't have that much of flexibility, then better prefer to linked list. Let's see first how we are dealing with C. Sorry, arrays. How we are dealing with arrays. Now, before going to implementation of arrays, first we discuss about the few topics of arrays. Few topics of arrays. Now, what is array? As we discussed, it is a collection of similar data types. Alright. Now, the array stores in the data in a continuous manner, and the size of array is fixed. So if I want to create a array with 5 elements, it can store only 5 elements. But if you consider the linked list, if I want to create a linked list with 5 elements, I can insert the sixth element also if I want to. Am I right? But arrays, it is not possible. So this is the what is array. Now let's discuss what is a declaration of array. Now if I want to declare an array, first I will declare the type, next array name and array size. Right? Type, array name, array size. For suppose if I want to create an integer value, here type is integer. If I want to store the characters of a array, then I will here declare as a character. If I want to store float values, here I will declare a float. Now I want to store the rule numbers. What is our IT code is 12. Am I right? So rule numbers are 1201, 1202, 1203. So these are integers. So I want to store the all the rule numbers of our IT students. Then the array should be like this. So 1201, 1202, these are integers only. So the type is integer. Then rule number is my name or name of the array, and 60. So in IT I have to store 60 members. Am I right? I have to sort the 60 members in IT one section. So for that 60 members. If I use this array like this, I can only store 60 values only. If anyone comes after 60, I cannot store. Remember this one. It is very, very important. The difference between array and linked list. In the arrays, if I have declared a element with certain values, with certain size, it can store only that much size only, that much elements only. If it is linked list, I can store more values. Now how to initialize the array? So already we discussed how we are declaring type, array name and size of the array. So if I want to declare or initialization means nothing but we are giving the values to the array. So there is a two types. While creation also you can give directly values. In a flower bracket you can give directly values, or after creation you can give like this: array name, index and value. Let's see some example here. So if I want to create a 5 rule numbers, array of rule number with 5 elements. So int rule number, the size is 5. Am I right? Now I write the values. Am I right? The first line, see the first line: type, array name and array size, value. So in flower bracket I gave the values 1201, 1202, 1203. Okay, in previous slide what I have done, in type array name, am I right? Here in previous slide what I have done, here first I declared a array. Now if I declared a array like this, then what I have to do for initialization? Then I will follow the second line. What is second line? So already rule number is created, then rule number 0, it is the element position. So I already discussed, if I have 1 to 60 elements, that means I have to start from 0 to 59. Am I right? 0 to 59. So it is the first element. So in first element I store 1201. So like this I have to store up to 59 elements. Now I already declared, already initialized. Now I have to accessing the array element. Simple: array name, index value. So for suppose if I want to access the second element, I want to access second element. What I have to do? Rule number 1. Why? Because see, element is second, but indexing start from 0. Am I right? So if I want to access second element, I will write like rule number 1. So 1 means 1 plus 1. If whenever the index is appeared, so for suppose index is 10 means 11th element, index is 20 means 21st element. So index plus 1 equals to position of the element. Now rule number 1 means 1 plus 1. So second element, I have to access second element here. So let's see the program. Here you already know the include function, that is the library. Now void main, here I created a variable with numbers. I give direct access as a first initialization the type int numbers 1201, 1202, 1203, like that. Am I right? Now I am accessing the values. So right now I want to access all the elements at the time. At a time, for that I have used for loop. Now for I equals 0, I less than 5. See, 5 elements only. That's why I less than 5. I less than 5. So I have only 5 elements. So it is starting from 0. So 0 first element, 1 second, third, third, 1 second, second, third, third, fourth, fifth, fourth, fifth. Am I right? If I directly put to less than or equals to means it represents the 6 elements. So it will give a error message. So I have 5 elements only. That's why I put I less than 5. If I execute this program, so student 1 number is 1201, student 2 number is 1202, like that will be printed. See here is the accessing. You can see to rule number sorry, numbers, my array name is numbers in brackets I will provide the index value. So now I am going to access 0 to 5th element, am I right? In I value I am storing the index value, so that index value is reflected by numbers I. So in each iterations from 0 to 5th element, 0 to 4th element, it will be printed like this. So this is the example for arrays. So already we discussed what are the arrays, the basic functionalities of arrays. Now we are going to discuss about how we are implementing that arrays into a linked list. Sorry, into a stack. How we are implementing that arrays into a stack. So if I want to create a stack with arrays, I have to mainly prefer these two variables. What are the variables? Top and max. Top and max. Now what is top? Top represents the last element which is available in the stack. Top represents the last element which is available in the stack. Max represents number of elements it can be stored in the stack. For suppose if I have a elements of 5, then max represents 5. Top, whatever the up to which level or up to which position the element is stored, that will be recognized by the. Now if I see top double equals to minus 1 means, see, you already see as a stack it has to store the values from 0. Am I right? From 0 to whatever the target I have, that one. Now, if the top equals to minus 1 means less than 0. So 0 is first element. So less than 0 means it is empty. Top double equals to minus 1 means it is empty. If top equals to maximum minus 1, it is full. Why? Because see, if I have 5 elements, 0, 1, 2, 0, 1, 2, 3, 4. So last element will be at 4. Am I right? So top equals to 4 means max 5 minus 1 equals to 4. So top double equals to max minus 1, that means the stack is full. If top equals to minus 1, then then the stack is full. Top double equals to minus 1 means it is empty. Top equals to minus max minus 1, that means the stack is full. Now let's consider this stack. So if I have a position 1 to have 5 positions, but addresses 0 to 4 and values are 10, 20, 11, 28, 12. Now if you consider the maximum value, in this I have 5 elements, am I right? See the positions. What is the maximum value? 5. Then what is the top value? Where I have stored the last element? I have stored the last element at the 4th address. Am I right? So top equals to 4. Let's see. Now top equals to max minus 1. Top is 4. Max minus 1 means 5 minus 1 equals to 4. So top equals to max minus 1, 4. Max minus 1. Am I right? So now stack is full. Am I right? It is right. Now let's do some operations on this. Now if I have the stack like this, so I have deleted the 3 elements, top 3 elements. If I deleted in the stack, now what will happen? See, max equals always 5 whenever the elements are available in the stack or not. If I have the maximum value is 5, that means max is 5. I can store up to 5 values. It won't change. Any operations are done on the stack, it won't change, but top will change. See, the last element, what is 20? 20 is stored in first address. So top refers to the 1. Top refers to 1. If I deleted the element again, then what will happen? Now the element is stored at 0th position. So top is 0, maximum is 0. Maximum is 5. Top is 0, maximum is 5. If I again deleted that element also, then what will happen? Top is decreased to the top minus 1, maximum is 5. Now let's see, top equals to minus 1 means elements are empty, stack is empty. Is there any elements available in the stack? No. Am I right? It is a empty stack. Now let's conclude this topic. Now what we discussed in this video, we discussed what is stack or introduction of stack. Now what are the operations we have to done in stack? What are the operations? 6 operations: essential, non-essential. Essential, I can insert, push, I can delete, pop, and the non-essentials pick for to know the top element, and size, to know the size of the stack. Is empty, whether it is empty or not, to check whether it is empty or not. Is full, to check whether it is a full or not, I can insert the elements or not. Those are will be used in operations. Now implementation of stack. So as we discussed, stack doesn't contain any special type of data structure. So for that purpose, for implementing stack operations, we have to do in two ways. One is by using arrays, second one is by using linked list. Now what is arrays? The array is a collection of elements. So for declaring elements, arrays, we have used type and array name and size of the array. And accessing also, array name with index we can access. Now for implementing arrays in a stack, so in general array declaration we have to use, or other than that we have to use two variables. What are the variables? Top, max. Top represents the topest element, the last element which is presented in the stack, and the max represents maximum values available in the stack. So let's, with this we can conclude this video. In next video I will explain how we are operating a array, how we are implementing array for a stack in a programming manner. Thank you.